Hi Geometry, this is Unit 1, Lesson 19 notes, which are on page 145 of our workbooks. So we're going to be talking about types of angles today. So one type of angle we're going to be talking about are supplementary angles. Supplementary means that my angles add up to 180 degrees. You might also be thinking of the word complementary with a C. Complementary angles add up to 90 degrees. So let's take a look, draw a line down through your page. Both figure A and figure C are going to be examples of supplementary angles. So let's take a look. This is a straight line. EAB would be a straight line. And straight lines always add up to 180 degrees. So if angle DAB, so we could say that the measure of angle DAB is 50 degrees. That's what this is telling us. I have enough information to figure out the measure of angle DAE. I know that together they have to add up to 180. So in my mind, I'm thinking about 180 minus 50, and I realize that my other angle has to be 130 degrees. So this would be 130 degrees. These are called a linear pair. A linear pair are a pair of angles. A pair of angles on a straight line that are supplementary and put in parentheses, add up to 180 degrees. And I wrote right on my line. Make sure you have that 100, not add up to 80, but 180 degrees. So let's take a look at figure C. We know that the right side of my graph, or on my line, sorry, is 65 degrees. So why don't you pause the video and find out the other side? And when you did that, did you get 115 degrees? So this side is 115. Oh, that's a few too many ones. 115 degrees. So now on the right side in figures B and D, we have another type of angle I'd like to talk about today. These are vertical angles. Vertical angles are congruent. Remember, congruent means that they have the same measure, they're equal in measure, are congruent. And across from each other when two lines intersect. So they're congruent to each other, which means they're equal in measure. So looking at my figure B, if I work slowly around it using linear pairs, I would know that if I look at my line this way, that if this little part's 30, then I know that this larger part has to be 150, so it adds up to 180. And then if I look at it from the other side, if I look at my straight line this way, and I kind of block that from my mind, again, it should add up to 180. So I know this little angle is 30 degrees. And then I can look at it from the underside. Again, this is a straight line. So if this is 30, I know the missing angle right here has to be 150. So working my way around using linear pairs, you can see that the angles directly across from each other are equal. They are congruent. So be careful, because the name is vertical angles, often students think they have to be up and down, but technically they're just across from each other. So really the 30 and the 30 are considered vertical angles, and the 150 and 150 are considered vertical angles to each other. So let's take a look at figure D. If I know that angle CAE is 135 degrees, the measure of angle CAE, you could have wrote the E first, EAC, but the A definitely has to be in the middle, is 135 degrees. Then I know directly across from it is also an angle that's 135 degrees. One last thing before we leave this page. When you have diagrams with multiple angles, you mark the ones that are equal or congruent with the same number of arc marks. For example, the 30 and the 30 with a single. And then I could mark the 150 maybe with a double. But I want to mark them differently because they are different measures. So let's use these two ideas with some algebra. If you could flip to the page after page 149. So 149 is our orange summary. If you could flip one more page, you have two blank sheets of paper. Pause this video for a moment while you copy down the two different diagrams I have for us to work on, and then begin the video again. Okay, welcome back. Number one, this example is an example of a linear pair. These two angles are next to each other on a straight line. I can cover up the other half, and I could see that together, these two angles make up a straight line. I can use that information to solve for x. So if this problem asked me to solve for x, I would be able to do so. I could set up an algebraic equation where this angle and this angle are equal to 180 degrees. I know a linear pair adds up to 180 degrees. And then I could use my algebra to solve. Let's combine like terms, and I would have 35x plus 5 equals 180. How about we subtract 5 from both sides to begin isolating my x term, and I have 35x equals 175. And let's finish by dividing both sides by 35. I had 35 times x, so I'll divide both sides by 35. And then I'll finally get that x is equal to 5. So if that's what my problem asked for, I'd be finished. If my problem asked for the measure of my angles, I would need to substitute my 5 back in to find out what it is. So for example, 15x is really 15 times 5. And when I do that math, if you need a calculator, grab it. But 15 times 5 would be 105 degrees. Oh, sorry, it's 75 degrees. I was thinking of my other one in my head. 75 degrees, thank you. And then if I substitute 5 in for my other angle, I'd have 20 times 5 plus 5. And that would be my 100 plus 5. That's my other 105 degrees. These two answers make sense because if this angle is 105 and this angle is 75, then they do indeed add up to 180 degrees. Let's take a look at this example. This example is an example of vertical angles. These two are directly across from each other when two lines intersect, so I know that they are congruent. I know they are equal to each other. I know that 7x minus 2 must be the same measure as 11x minus 34. So let's set them equal to each other if they are congruent to each other. So you can solve this a couple of ways. I'm going to go ahead and move my 7x over by subtracting 7x from both sides. When I do that, I have negative 2 equals, what do I get here? 4x minus 34. I'm now going to add 34 to both sides. Again, trying to get all the x terms on one side and all the constant terms on the other. Once I've done that, I'm going to divide both sides by 4, and I know that my x is equal to 8. If this problem had said solve for x, that's my answer. I'm done. I've done what it's asked of me. If instead the problem said to find the measure of the angle, I need to substitute the 8 back in. So 7 times 8 minus 2 would be 56 minus 2, or 54 degrees. And I know the other angle would also be 54 degrees because they should be equal to each other because they are vertical angles. Please flip back to page 147. On this page, in activity 19.3, we're going to talk about how we know that vertical angles are indeed congruent. So if you would take a moment and mark points A and B on your diagram and points C and D on your diagram, and where the two lines intersect are going to be point A. So my thoughts about vertical angles are that they are congruent. So notice I mark the two angles directly across from each other, the smaller ones, with a single pink arc. And I'll mark the two larger ones with a double purple arc to show that I believe those angles across from each other are congruent. So what's my relationship between my vertical angles? I believe that my vertical angles are congruent. So vertical angles are congruent. So in this diagram, for example, I believe angle AED, that's the pink on the left, angle AED is congruent. This is a congruent symbol that we haven't used a whole lot yet. We'll use it a lot during Unit 2. It's an equal sign with a tilde. It's congruent, for instance, to CEB. E has to be in the middle because that's my vertex. So these are that vertical angles are congruent. My two pink ones, my two purple ones. How do you know your conjecture is true for all possible pairs of vertical angles? So I want to go back to something that we've learned in our book, and I'll flip back so you don't have to, but I'm flipping back to page 73. On page 73, this is the summary for lesson 10, and we said a figure is called congruent to another figure if there's a sequence of translations, rotations, and reflections that take one of the figures onto the other. So these were my translations, rotations, and reflections. So if I'm looking at this vertical angle, I'm going to show that they're congruent by using the definition of congruence. So let's take a look at this diagram and see how I can do that. So with my patty paper, I've marked my A, B, C, D, and E, and my two pink angles, and I'll also mark my two larger purple angles. So if I can get any of these angles on top of the other one by doing a rotation, a reflection, or translation, I can show that they are congruent. Let's focus on the pink angles for 1 minute. What if I did a rotation of 180 degrees around E? So I swing this around 180 degrees, and what do you know? My two pink angles line up on each other again. I showed that by showing I could do a rotation and line the pink angles up with each other. How about a reflection? So if I considered a line, the perpendicular bisector of angle AEC, because remember, we can't reflect over a point, we have to reflect over a line. And I folded my paper on that line. Wow, I can see my two pink angles lining up again, showing that they're congruent also because I can reflect one onto the other one. So using the definition of congruence, you can, one, rotate, and I'm going to rotate the figure 180 degrees around point E, counterclockwise or clockwise, doesn't matter. And the angles line up again, showing that they're congruent. I also did it as a reflection. So 2, let me move my camera for you. So 2, I also reflect the figure over. My line of reflection was the angle bisector of AEC was the one I used. That was the line I folded over to fold my 2 pink angles on top of each other. So I reflect the figure over the angle bisector. I'm going to abbreviate angle with an angle symbol and bisector with BIS of angle AEC, and the pink angles in this case line up. I could do it the other direction to show my purple ones do as well. So I've proven my vertical angles are congruent by using my rigid motion transformations. That is the definition of congruence with our lesson 10. So let's take a look at doing these transformations in our practice problem number 2. So if you could flip to our practice, this is our unit on page 150, our unit 1, lesson 19 practice. I'm on page 150, and we're going to look at number 2 together in this video. So if I could slide it up, this is number 2 on page 150. So it says select all the statements that are true about this figure. So why don't you take a moment and pause this video and take a look at A through F and see which ones you think might be true or false, and come back and we'll go through them together. So welcome back. I will say the first thing I've done is on patty paper, I copied my A, B, and D line and my E, B, and C line. I also added in my angle D and my angle B. I did change things a little bit. I already know about vertical angles. I changed this to a double arc and this to a double arc to show that all 4 angles aren't congruent. Our book does this all the time. And so I wanted to make sure I showed them as different to you. So what I have on my patty paper is exactly what I have on the book as well. So let's take a look at this. Number 1 says C plus B equals D plus C. So let's look at this. Angle C plus angle B. Well, if I look carefully, C plus B is on a straight line. So I do know that C plus B would be equal to 180 degrees. They are a linear pair that we learned about in class. And then D plus C. Well, let me look at D plus C. D and C are also on a straight line. They're also a linear pair. So D plus C would also have to add up to 180 degrees. So it looks like A is true. They both equal 180, so they would be correct. B, D plus B is 180. So D and B are straight across from each other. I don't know anything about adding up to 180. I do know they're vertical angles. So actually, I do know they're vertical. I'm going to abbreviate vert and then my angle symbol with an S. I do know they're vertical angles. I know they'd be equal, but I certainly don't know if they're both 90 by this diagram. There's no right angle mark, so I don't know that they add up to 180. And I knew this one up here because they were linear pair. Okay, you guys, let's take a look at C. Rotate clockwise by angle ABC. Oh, geez. Using center B. Okay, rotate clockwise by using this angle. Then angle CBD, which one's that? CBD, that's my little b, is the image of ABE. Okay, so that's this D. In other words, they're saying these two are going to go on top of each other. Okay, let's check it out. Rotate by angle ABC. ABC. So I'm going to rotate by this angle. So in other words, you guys, if I'm going to rotate by this angle, whatever degrees it is, I'm going to bring A all the way over to C. I'm going to like close it. kind of if you could think of a smiley face or a Pac-Man, I'm going to just close this entire angle. I'm going to rotate A all the way over to the other side, whatever it is. So let's rotate A over to C. And when I do that, yeah, B did not make it on top of this angle. And D did not make it over to here. It had to rotate a little bit more. See, it didn't make it all the way around to line up on top of each other. So this doesn't work. Okay, so now it says to rotate 180 degrees using center B. And again, it's saying that CBD, that's this guy, CBD, is going to line up with EBA, this one. Okay, so let's try it. So I'm going to put this up here, and now I'm going to go 180. So in other words, sorry. So in other words, I'm going to basically, E is going to flip all the way over to C is what's going to happen. Or you could think of A flipping all the way over to D. That's 180 degrees. Think about half a circle. So I'm going to flip E all the way over to C. And when I do that, what do you know? My little pink angles are back on top the other one. They did make it all the way around. They are lying on top of each other. So this certainly worked. So why don't you try E and F and then check your answers with our practice solutions. Thank you very much.